right, in this video we are going to be talking about, two-column proofs, right? So what we're going to do is we're going to construct proofs. We're going to write the convincing arguments that we have been doing recently in all of these flowcharts. But this time what we're going to do is we're going to put it into two-column proofs. So instead of with our flowcharts, it'll look like two columns. So let's start off with a flowchart and then figure out how are we going to put that into a two-column proof. All right, so here's our first problem. So Ainzel has done a lot of proofs using congruent triangles. Now he wants to challenge himself to prove the conjecture, so again it's a hypothesis, opposite angles of parallelograms are congruent. So he's trying to prove that A and C are equal to each other, but to prove it without using congruent triangles. Interesting. Okay, so he starts by creating the diagram below. So go ahead, pause the video, and try to and fill in this flowchart for what it has. All right. So hopefully we've copied the flowchart onto our into our notebooks. So let's look for some context clues. All right, what's the first thing that he started off with? He's starting off that this is a parallelogram. So chances are in here, that's exactly what we're going to write. We're going to write that T, U, V, and W is a parallelogram. So it might not fit in mine, so bear with me. So T, U, V, W is a parallelogram. So that's what we should put into our first oval. Why are we putting that? Well, because he gave it to us. So this would be given information. Okay, so now let's look at some more context clues. What's important about a definition of parallelogram? Well, definition of a parallelogram, if we remember, we said that a parallelogram has two pairs of parallel sides. So that's really important. So that means that this side is going to be parallel to that side, this side is going to be parallel to that side. So we can kind of see that we have a TU, right here, is parallel to WV. So that means I'm not going to put that information in this one. I'm going to put the other one. So I'm going to put this side. So I'm going to put TW is parallel to UV. And I said definition of parallelogram here. So that means that this is the same thing. So def of parallelogram. Okay. So what do I notice about this? It says B is equal to C. Well, now that we've said that these are two parallel lines, notice that B and C are both on the same side, but they're not both interior, they're not both exterior. What they are they are in corresponding parts, right? So notice that this is above the parallel line here. This one also is above it. So since C and B are equal to each other, these are your corresponding angles. So corresponding angles. And I should say parallel lines lead to corresponding angles congruent. So parallel lines lead to that. And so notice that this one says parallel lines are leading to alternate interior angles, which means that these two then are equal to each other. So inside I should be writing A is equal to B. Okay, so if B is equal to C and A is equal to B, that means I can replace every B with this C. So by substitution, I get to say A is equal to C, which notice opposite sides of a parallelogram are congruent. We have officially solved and proved this problem. Okay, so get a little, maybe hopefully a little bit easier now that we just fill in the blank. So now what we're going to do is we're going to talk about how this is a two-column proof. All right. So notice that we always have something written in an oval, and then we always have to have a reason behind it. So we have statements and we have reasons. Why are you writing this? This is because. So another way to organize it is a two-column proof. You could also write a paragraph. Usually proofs, two-column proofs or flowcharts are easier. So instead of using arrows to indicate, right, we just list it in linear order, right, first to last. Okay, so let's complete this chart. So notice it said TUVW is a parallelogram, and it's given. Notice that that was the top piece of information. So now comes the next two pieces of information. So let's look at this. So it says the definition of a parallelogram. Again, I don't want to use TU, so I'm going to use this one, the TW and the UV. So TW and UV, right? So we get to say that. And again, I get to say that because it's the definition of a parallelogram. This information is also a definition of a parallelogram. Now, if both of these spots were blank, you can switch these two rows. It does not matter which one you write first, but it needs to come before this piece of information. So B was equal to C, so let's see what we wrote. We wrote parallel lines are corresponding angles. So that's exactly what we're going to write here. And you can write it out in a sentence. So notice it says, if lines are parallel, then alternate interior angles are congruent. So we can write something like that. If lines are parallel, then corresponding angles are congruent. Again, use symbols to help you out. So that's why B is equal to C. If lines are parallel, alternate interior angles are congruent. So that's your A is equal to B. So that's exactly what we're going to put. A is equal to B. And then ultimately, what are we trying to prove? We're trying to prove that A was equal to C. So by substitution, I get to write this information out. A is equal to C. So again, this is just another way to write down some flowcharts. So let's give it another chance, another whirl. Again, this is kind of a fill in your own. So a line is a perpendicular bisector if a line segment of a line segment, if the line is perpendicular to the segment, which means that it's 90 degrees, right? And passes through the midpoint of that segment. So notice that there are two pieces of information. Okay, I'm going to erase that because we don't actually know if that is perpendicular or not. So in the figure at the right, PM, bam, right here, is perpendicular to AB, and M lies on that point. Excellent. So I get to draw that in because it is perpendicular. So copy and complete the two-column proof to show that P is equal distance from point A to B. So basically what we're trying to do is we're trying to prove that this guy and this guy are the same, are basically the same parts. Okay? So let's start off with what we know. It says, statement, PM is a perpendicular bisector of AB, right? Why? Because of this piece right here. It was given information. Okay? What do we know about given information? Definition of perpendicular. Well, that means that it's 90 degrees. So that means that not only is this also 90 degrees, this side is also 90 degrees. Okay? So we are going to say that the measurement of, and again, I can't use M because I don't know which M I'm talking about, so let's use three letters. Let's go AMP, my bad, AMP, and also BMP. So this is also equal to the measurement of BMP, and everything's equal to 90 degrees. Okay, so again, sometimes you can add, instead of writing out two ovals, we can just have one thing. Definition of a bisector. So what does that mean? It means it's cut into two equal pieces. Again, this could be a bisector of a line. This could be a bisector of an angle, right? Notice it didn't say bisector of an angle, but it did say that M lies on AB. So we are going to say that AM and BM are the definition of a bisector. So AM is congruent to BM. Okay, again, definition of a bisector. So now what I'm trying to figure out is I need to get this to be the same. So I'm going to say, since I have this side and this side to be the same, I have an angle, I'm going to use PM, right? Because again, I see at the bottom, this is like CPC, TC, right? congruent parts of congruent triangles are congruent. So I'm going to use PM. So let's say that PM is congruent to PM, right? This is your reflexive property, or aka segment is congruent to self. And so we just found out is we have a side angle side. So we're going to say side angle side congruency, and I'm just going to say that triangle AMP is now congruent to triangle BMP. Since they are congruent, all sides have to be equal to each other, so all angles have to be the same, all sides have to be the same. So now I get to say that PA is congruent to PB. Again, don't forget the line segments on top. It's hard to see. Okay. Again, you're only going to get better at this the more that you try and put yourself out there. So what I want you to do is in the next video, I'm going to answer these two questions. All right. So each pair of triangles below, copy them into your notebook. And what we're going to do is we are going to make 2-column proofs. Right. So again, 2-column proofs for this guy. Right. We'll probably need some more. Probably need more things, but just remember that you are going to put statements. So S for statements, R for reasons. What are you going? What are we trying to say? Okay. So we're trying to figure out. Ultimately, for this one, we're trying to figure out why is ACB congruent to triangle ECD. That's what we're trying to prove on this one. Okay, and it is possible. Okay. Finally, for this one, what we're trying to we're trying to prove that triangle GKH is congruent to triangle MPN. So again, try to prove these on your own using a 2-column proof instead of our normal flow chart. You can always use a flow chart and then bring it back to the 2-column proof, but stop, the video will stop. Go ahead, try it. When you're done trying it, pop up the part 2 to see how you did.